All right, so we are starting Chapter 1, Section 4 for IM3. This is solving absolute value equations. So the first thing it's going to have us do is identify what is absolute value. So we're just going to define it's the absolute value. So the absolute value of a number is its distance from 0 on a number line. So that means we're not really looking at positive or negative. We're kind of looking at left or right. How far away is it from 0? So we don't call it negative or positive. We say the absolute value is, and we say how far away it is. So there's 4 steps here that we want to take a look at. I'm going to scooch this up so we can see all 4 steps here. And these steps may be a little what I would call arbitrary because it kind of depends on the teacher and how they would combine the steps. But I'm going to go ahead and write out the steps the way that I see it. So first we want to isolate the absolute value. Okay, so let's look at an example of what it means to isolate the absolute value, just really quick. So I'm going to have this example, 3x minus 2, the absolute value of 3x minus 2, minus 8 equals 1. So here's my example. I want to isolate it, meaning I want to get it by itself, just like I would with the variable when we were just dealing with equations in one variable. So I'm going to do the opposite of what's being done. I'm subtracting 8. Well, I don't want there to be anything other than the absolute value on that side. So I'm going to move 8 to the other side by using the inverse. So I have 3x minus 2, absolute value, and these cancel. And then I'm going to add these together, and I have 9. So now I'm ready for step number 2. So step number 2 is we're going to set the absolute value to both the negative and the non-negative values. So it's kind of a fancy way of saying we need to look at how it's going to the left and to the right, because we're looking at from 0 on the number line, right? So the first one you write should actually be the non-negative. So I'm just going to drop these absolute value, and I have 3x minus 2 equals 9. This is case number 1. And then I should have case number 2, which goes in the opposite direction. This went right. Now I'm going to go left. So I have 3x minus 2 equals negative 9. Case 2 should always be the negative 9. When you drop these and you write case 1, if you're dealing with a negative already, that means you should stop. It's no solution because we can't start with a negative. Not an absolute value. Remember, absolute values aren't negative or positive. This doesn't mean positive 9. This just means 9. Just 9 units away is what it means. All right, so now we've set the value to both non-negative and negative and non-negative values. Now we're going to go to step number 3. So step number 3 is to solve both equations. So if I start to solve both equations here, I want to do the same thing I would do to solve any other equation. What's being done to the variable with addition or subtraction? I'm subtracting 2, so I'm going to add 2. So I end up with 3x, negative 2 plus 2 cancels out, and I have 9 plus 2, which gets me 11. Now I'm going to divide by 3. So 3 divided by 3 cancels, and I have x equals, let's see, what's 11? That's going to give us a decimal here. So I'm going to have 3.7. I'm just rounding that. So it would be, 6 forever. It's a repeating decimal. I'm just going 3.7. Be careful about rounding. Only round the way that Alex tells you to round. If you don't round correctly, it will probably mark you wrong because you're not following the directions. So just be careful about those directions. So we're actually going to do the same steps on case number 2 because we're still subtracting 2, so I'm going to add 2. But it's going to behave a little differently now. So this still cancels, but now this is a -9 and a +2. So I'm going to end up with -7 instead of +11. Still going to divide by 3. And I'm going to have x equals -7 divided by 3 is -2.3. And again, I'm rounding that. Be careful about the rounding. So the very last step here, we'll do this in green, I guess, is to check your work. So if we go back up to the top and we say 3x minus 2, that should equal 9. So we want to make sure that works. Actually, 3x minus 2, absolute value. I'm going to go back all the way to the top here, like this. I'm going to use this one. So I'm going to plug in 3.7. So 3.7, this is a multiplication sign. Absolute value, minus 2, absolute value, 8. All right, so we have 3 times 3.7, and we get 11.1 minus 2. Remember, the absolute value is, we do drop negative signs, but not until we get down to one number. Okay, so 11.1 minus 2, and we have 9.1. It is positive. It doesn't matter if it was positive or negative. We would drop the negative sign, and now we can drop away the absolute value, and I'd subtract 8 from that, and that would give me 0.1 equals, 1.1 equals 1. So this is all, it looks wrong. The problem here is with the rounding. If I hadn't rounded, it would probably be perfectly fine. So I had an issue with rounding there. So this is pretty close. I can see it's only a 1/10 off. I'm going to assume it's because I rounded by my 1/10 there. All right, so the next piece we want to check. So I'm going to say that one's okay, even though it's slightly off. Again, I'm just attributing that to my rounding. So I have 3x minus 2 minus 8 equals 1. Sorry, I didn't say absolute value there. So I have 3 times, I'm going to check this other one, -2.3, and this is a time symbol, minus 2 minus 8 equals 1. All right, so 3 times 2.3, we get -6.9 minus 2 minus 8 equals 1. So now, remember this is absolute value signs. I'm sorry, sometimes when you're drawing them, just try to make them a little bold so that you don't mix them up. So now I have -6.9 minus 2. Remember, they're both negative. I'm going to combine and keep the negative sign, but it's absolute value, so I'm actually going to drop it away anyway. So it's -8.9 minus 8 equals 1. So now we end up with 0.9 when I subtract these equals 1. Again, I'm off by a 1/10, but I'm assuming it's because I rounded. If I hadn't rounded, I would probably be perfectly fine there. It would work out exactly. So keep that in mind. When you round, you do have to pay attention to that when you're checking your work, but this worked out perfect because I was able to check it. All right, so those are our 4 steps. Let's go to the next page here. Scooch down. So what are extraneous solutions? So this is a definitely important thing to pay attention to. So extraneous solutions are answers that may not be actual solutions. So let's write that out. May not be actual solutions. And we call those extraneous solutions. This happens a lot if we have some kind of limit or constraint in the problem, and the answer or the solution we receive breaks that constraint. So, and an easy one to compare this to is if we're being asked to find a measurement and we end up with 2 answers from, say, an absolute value, but one of them ends up negative. Well, measurements can't be negative. They have to be positive, right? So it just depends on what we end up with, but measurements are an easy one to compare this to because a lot of the time, and it's not necessarily absolute value in this one, but when we're factoring, usually like if we have something, like this, and we end up factoring this guy, we end up with 2 answers. That makes sense. The square tells me there's 2 roots there. But if it's the measurement that we built this off of, one of those may not be accurate if it's negative. Now, in this case, they would actually both be negative roots. But it's just an example I was throwing up there just to be funny about it. But it's just answers that may not actually be solutions. So we have to be aware that not every single solution we come to is actually a solution. All right, so let's go ahead and evaluate an expression with absolute value. So evaluated expression usually means that they're going to give us something to plug in. So we have this absolute value expression, and we want to plug -2 in here. So I have 4 times -2, and we have an absolute value sign here, plus 3, absolute value, minus 3 1/2. You could also write this as 3.5, which I would prefer to write it as. For whatever reason, I think that's a little easier to combine. So we're going to go ahead and multiply in here first. So we're going to reduce the absolute value first, just like it's parentheses. So we have -8 plus 3 minus 3.5. So -8 plus 3 is -5, because a negative and positive, but the absolute value, I'm going to drop the negative away, and it's just going to be 5 minus 3.5. And now I just subtract like I normally would, and I get 1.5. All right, so we're going to do the same thing here. So we have this expression with an absolute value, and I'm going to plug in y. So I have 1 point. If I wanted to write this out, it would be 1.3. I might be careful about this one because that's rounding. Technically, this is a repeating decimal. So I'd actually be careful about that. If you haven't been given any instructions on rounding, I would probably leave it a fraction in this case, just so that I don't get in trouble with that when I go to click turn in on Alex, and then it says, you've rounded incorrectly. All right, plus 1. Okay, so we have 1 1/3 minus, now we're going to multiply, so 2 times 2 is 4, so we end up with, this is absolute value, not a 1, -4 thirds plus 1. All right, so now we have -4 thirds plus 1. Remember, this 1, if I wanted to combine this pretty easily, I can change it so that I can divide it up the same. If it's 1, it means it's 3/3. So now I can kind of quickly combine these ones, and I'm going to start writing it up here so I have enough room. Oops, minus. So I have -4 plus 3. I end up with -1/3. But remember, that absolute value is going to drop away, and I'm just going to have 1/3. This negative came from the outside of the absolute value. That stays there. Okay, that doesn't drop away. Only negatives inside the absolute value drop away. So now I have 1 1/3 minus 1/3. So I just have 1. All right, solve the absolute value equation. Does it have 1, 2, or no solutions? So first, we isolate the absolute value. So I'm going to divide both sides by -2 to isolate. So this cancels, and I just have 3a, absolute value equals 6. Now I can do -3 on that side. So now I can do case 1 and case 2. And I end up with 3a equals -3. Uh-oh, case 1 can't be negative. So right away, I stop and go, no solution. I can't do this. Remember, case 1 needs to be positive. I can't start with a negative. All right? So number 4 here, let's take a look at this one. Again, we want to isolate the absolute value here, this guy. All right? So I'm going to first do the same thing I would normally do to get a variable by itself. Treat the absolute value just like a variable. So what's being added or subtracted? An x. So I'm going to add x to both sides. I get 2, absolute value of x plus 1 equals, this cancels out, so I don't have to bring it down, 4x minus 4. Now I'm going to divide by 2 because I want to remove that as well. And I have x plus 1. Absolute value equals 4 divided by 2 is 2. 4 divided by 2 is negative 2. Sorry, negative 4 divided by 2. Remember, we're dividing both pieces. Not just one or the other, both. Everything is divided by 2. All right, so now I've isolated my absolute value, and I can write my case 1 and my case 2. So case 1, and we'll see where I write case 2. I might end up writing it up here because I'm going to need a little bit more room for this one. X plus 1 equals 2x minus 2. And case 2, I'll just go ahead and write it up here. Case 2, I have x plus 1 equals negative 2x minus 2. I put the whole thing in parentheses because I have to remember to apply that negative to everything. It's applied to the entire side. All right, so let's go ahead and start solving. So we need to get these variables on the same side. So I'm just going to go ahead and subtract 2x. So I'm bringing them over to the left. And you could also move the number, the constant, at the same time if you wanted to, but I'm going to do it in pieces here. So x minus 2x gives us negative x plus 1 equals 2x minus 2x cancels. We're going to subtract 1 from both sides. That guy cancels. We have negative x equals negative 3. I don't want to know what negative x is, so when you end up with this situation, remember, it's really like multiplying by negative 1, so I'm going to divide it to the other side, which really just flips the signs. So I go from negative x equals negative 3 to x equals 3. All right, so this one, we're going to do the same thing. Oh, before I do that, though, let's distribute that negative sign so we end up with negative 2x and positive 2. Now I'm going to subtract 1 from both sides. And we have x equals, and I'm doing the 1 first instead of the 2x. Really doesn't matter which one I do first. I just have to start moving something. So these guys cancel. Negative 2x plus 1. I'm going to add 2x this time. So I end up with 3x equals 1. And then I have to divide by 3 to finish here. And I'm sorry, I'm kind of running into the words there. So I end up with x, because 3 divided by 3 cancels, equals 1/3. So you definitely want to make sure you go back and check these to make sure they are correct. It does happen where you get to the end of the problem and you go, oh no, I forgot to do this part, or I forgot to switch the negative sign. I forgot to distribute the negative sign. So you want to make sure you go back and make sure it all works correctly. Why did the 3 disappear there? That's interesting. So if I plug in 3 here for all of these x's, then I would have 3 plus 1, which is 4, times 2, which is 8. 8 minus 3 is 5. So I'm just kind of, the whole left side equals 5 there. And then on this side, I'd have 3 times 3. That'd get me 9. Minus 4 is 5. Yay, 5 equals 5. That means we did it correctly. So I know I did that kind of out loud. I didn't write it out because there's not a whole lot of room to write this out. But that's the idea of checking it. It's just plugging it in, making sure that is in fact what we get. So if we do 1/3 here, we have 1/3 instead of 3 on all of these pieces. So 1/3, and remember that means that this is 3/3 when I want to add these together. So that's 4/3 times 2. So that's 8/3. 8/3 minus 1/3 is 7/3. Sorry, I know that's a lot of thirds. Now we have 3 times 1/3, which cancels out to 1. And 1 minus 4 is, let's see. Uh-oh, did something go wrong? Did I do something incorrectly? So see, this is an important part of checking your work because I think something might have gone wrong here. So let's see, we have 1/3 plus 3/3, and it could be my answer. I'm just going to go back and check my work really quick just to make sure. So times 2, that gets me 8/3. Minus 1 does get me 7/3. times 1/3, which would cancel down to 1. So the problem is on this side, I'm getting -3, which those definitely don't match up, right? So we're off by a little bit here. We're actually off by 2/3. So let's see. We do something funky up here. Subtracted 1, I subtracted 1, and it was 2x minus 2, negative 2x plus 2, so that should be good. Oh, I see my mistake. Nope, I'm subtracting. That's not my mistake. I was thinking 3 here, but nope, that should be a 1. X equals negative 2x plus 1 plus, we get 3 and 1, and we get 1/3. So this may mean that it's an extraneous solution, actually, on this one, because I don't see my mistake. So I hope I'm not just missing it, but checking my work, it still works out exactly the same way each time. I don't see my mistake. So if I made a mistake, you can always comment on my YouTube video and tell me where you found it. But right now I don't see one. So what I'm thinking is this means that it just has one solution. This second solution, this 1/3, doesn't actually work. So only x equals 3 works. And that's another reason to check your solutions also, is to make sure that both of them actually work and you don't end up with one of them correct and one of them incorrect. So just another very good reason to check your work, because this is just what we would call extraneous. All right, let's do this last one. It's already isolated, so we can do case 1, which we just drop this down. And case 2, let's see, where are we going to do case 2? I need more room here, dang it. Oops. All right, I'm going to throw case 2 up here. Sorry, I know this is getting pretty busy. All right, case 2, we have x plus 12, but it's going to equal -9. All right, let's go ahead and solve this. This one's pretty dang quick to solve here, because we just have to subtract 12, and we get -3. And then we're going to subtract 12, and we get x equals -21, right? So 21. So we have to check our solution, just like in the last one. We need to make sure it actually works. So we have -3 plus 12. That would get us 9. The absolute value of 9 is 9. So 9 equals 9. Yay, that's correct. So we're good to go there. Let's check the second one. So we have -21 plus 12. So -21 plus 12, that does get us -9, but remember we get to do the absolute value, so we get 9 equals 9 again. So both of these solutions do work. So this one has 2 solutions instead of just the 1, because both of them worked correctly. All right, I believe that's the end of section 4. So I'm glad we kind of ran into this situation where I had to go back and check and make sure that I didn't do my math incorrectly, because that could also be the problem, is that I just did one of my steps incorrectly. So always go back and check, but part of the reason for checking your solution is not just to make sure that your math was right, but to make sure that both solutions actually work. All right, well, I will see you in section 5.